This is Don Larson speaking. Welcome to our webinar today on S1000D Compliant Technical Illustrations. We will get started in just a moment, but we're going to go to pause just to allow a few more attendees to join us. So please stand by. Okay, this is Don Larson again. We're ready to get started. Before we get started, though, let's just review the webinar rules, or housekeeping rules, just quickly here. If you're experiencing any problem, please use the chat function, the webinar chat, to communicate. All attendees will be muted for the duration of the webinar. There are some associated materials that are available via download link that we'll put in the chat bar or chat. And if you should have any questions during the webinar, please post those in the chat panel, and then we'll have a Q&A period at the end. And if we don't, by any chance, get done with everything, we'll make sure to reply with an email to you. For those of you not familiar with Larson Software, we're based in Houston, Texas. We are actually founded in 1984 as graphics technology experience, and have been doing that for over 30 years. In the beginning, we promoted the CGM usage by providing a free CGM viewer in the beginning, and then we are also a member of the CGM Open Foundation. The foundation is responsible for maintaining the CGM standard and keeping it viable. We develop our product is developing powerful 2D and 3D technical illustrations based on open standards. We were the developer of the first HTML5 viewer that eliminated the need for a plugin. We also introduced the first CGM profile, which then became part of the S1000D profile for SVG, when we also support that as well. So with that, I'll now turn it over to David Manik for the main part of our presentation.
Thank you, Don, and good day to everybody for joining, and thanks for joining us today. Yeah, we're going to cover the subject of S1000D Technical Illustrations, perhaps give you some guidance on how you might create them and display them in your projects. As Don mentioned, if you have any questions, we're using a different platform today for the webinar, so please post your questions in the chat panel, not in the Q&A. That doesn't seem to be working correctly at the moment, so please post them in the chat panel, which you should see at the top of your menu bar. Yeah, so thanks for attending. We're going to make a start. There's quite a lot to go through, plus quite a few different demos. And as I said, if you've got any questions, just post them in that chat panel. So for those not familiar, the S1000D specification really was introduced in the 1980s, so quite a long time ago, around actually the formation of the company founded by Don, Larson Software. So the main concept is that it's modular, or the data modules themselves, as the name suggests, are modular, also known as DMs in the short term. The objective really was to create a more flexible way of managing and publishing technical documentation. And today, S1000D is widely adopted and accepted globally as a standard of producing and distributing technical documentation. One of the critical areas or components of the information, though, is the graphics or the illustrations, multimedia. And this really is a critical component to go alongside the text that you find in the data module. If you're interested in the spec, then please visit s1000d.org. There you'll be able to download the latest specification, and also there's a lot of samples and some of the data we use today you can download from there as well. This is just a little infographic we created. So we've actually put this in, the link is in the chat now if you want to download some of the materials from today. So this is just an infographic we actually created to describe the standard in simple terms. So if you want that, then please go to the download link and you should be able to get that. So as an overview, everything was actually showing today or is based today on is issue 6 of S1000D, which is the latest specification. So all the chapter names and numbers that we give you here should correspond with the spec if you've downloaded it. So what we'll be doing is going through the 2D illustration guidelines. And I do say guidelines because that's what they are. They're not exactly rules, but we'll cover that as we go along. We'll also look at the 2D file format, CGM and SVG. And also we'll look at the 3D guidelines, which are actually in that spec as well. And also talk about 3D file formats as well as we go along. So just to give you an overview of the workflow, and we'll actually cover some of this in the demo today, is that probably the majority of new illustrations will be now sourced from CAD data, and they could be then converted to 2D or remain as 3D and be used in the technical documentation. So we'd probably originate from a 3D side as a step file from the CAD system. That's not something we'd use downstream though. It would really be used to create the information from either 2D or 3D. We wouldn't want to actually store that step file, say, in our common source database. But you could have legacy illustrations as well, which already exist, which could be in CGM or TIFF, depending on how they were actually developed and created. And these illustrations, either CGMs or SVGs, could be stored in your CSDB. You then downstream, you go into you build your IETM, your Interactive Electronic Technical Manual, and then you'd need some way of actually viewing those graphics or illustrations, either as a 3D viewer or as a 2D viewer. And each of these illustrations would have a unique number, as the data module code has a unique data module code. You'd have an ICN or information control number to identify each illustration or multimedia asset. So let's look at those guidelines to begin with. So you're looking at chapter 3921. So don't worry if you don't have to make notes as you go along here. We will again distribute these slides, and as I said, the link is in the chat, so you can get a copy of these slides in PDF form. So this is where all the illustration information or guidelines is documented within the specification. It's pretty straightforward that you want to, all illustrations should communicate simply and economically way of actually enhancing the technical information, in other words, the text. So usually that would be, the technical writer would say if there's an illustration required to support the text to make it more usable for the maintainer to actually do the repair perhaps. And there are two main illustration types which we talked about, which would be new and a legacy, depending on your project. So one of the guidelines is that it recommends you use an isometric projection for your illustrations. And that kind of makes sense, especially if you're using illustrations that are in an IPD, because then what you want to do is obviously reuse parts and everything looks the same and consistent across that illustration. So isometric is a good choice, definitely, even today where you might have 3D information. There's also illustration page size, which is probably less relevant today, especially if you're distributing electronically, because you can zoom in, zoom out, and so forth. But if you were still printing pages out, then that would become more important. Obviously, line weights, line styles, and annotations, you want some kind of consistency across those. So we also, you might want to use color. And sometimes color can help if you want to show some clarity around the illustration. This is just black and white of the example on the right, but there is what we call a business rules decision point where you can, for your project, say, we want to use color on this because it's going to help the final deliverable. So symbols are quite important as well. The spec does give you some ideas of what symbols should look like to be consistent again. So say for forward and backward and tops. So just simple arrows. Again, for simplicity's sake, just use these and they will then make you consistent across different projects. And the use of color, as I said earlier, could help sometimes identify parts. So this is the guideline, is that yellow means that the item is attached to the main assembly, and then light blue is actually the parts of on the illustration, so something you could order or disassemble, and then gray means that they could be on subsequent illustrations but not actually on this one. So you could have a link, perhaps where it says C, you could have a hyperlink that then takes you to that other illustration. The colors really come over mainly from commercial aircraft, so that's where you'll see probably more color than say military projects. And this is the color palette, so there's actually a color palette in the spec as well for what colors you should use. So these are all defined within the spec. We created a bit of a guide illustration. I didn't include this in the download, but if you we actually is on our website as well, which you can get to and download this as a CGM file if you wish, and it's just a template file. CGM, it's a CGM file, so you could open it within your software if it supports CGM. We also created another infographic around the ICN, the Information Control Number, which shows you the breakdown of what that is. So this would be the equivalent of your data module code. So it shows the platform, in this case the bike, the S1000D bike, and then the different constructs that you would go through to name it. As an illustrator, if you're the illustrator though or writer, you're probably not responsible for actually issuing this number or creating this number. You probably will be given it and then create an illustration appropriate to it. But that just gives you an idea of what these different numbers mean within there. And that is in the download of materials, that infographic, if you want to have it. Oh, so then the next part is the first demo, which is a PhysX edit, and I'll just quickly go through some of those rules within the software itself. So this is the illustration. I've now just positioned this over here as well, so we can put like an image in here as well. So this is a CGM file. We can see some of the hotspots on here highlighted. We can see the colors here that are appropriate to the spec. And what we've done over here is, say in this section here, this is PhysX Edit, is that we've created all these colors as defaults, so we can then use this. We know we're using the correct colors for S1000D. We've also created line weights as well that are appropriate to what's in the guidance, and the hotspots would appear over here. Again, they would be actually done to the specification. So so if we kind of highlight one of these and modify, we can see that it's got an ID and a name which is appropriate to the standard. The other thing I've got up here is within Visit said it's the library. So we've put some of the symbols in here, so you can drag and drop those onto your illustration just by clicking on them. And anything else within Visit said it you could save as a library item. So any parts and so forth that you want to bring in, we could also do that as well. So you could have specific S1000D symbols or parts. And then what I can do is if I've here, I can save this as a template. I probably wouldn't save this one, but you could save as a template once you've set everything up for your particular project, and then everybody could work to the same template, same line weights, and so forth. Okay, that's the first demo. Let's just go back to the slides. So now we'll talk about a bit about file formats, 2D file formats, in this case CGM and SVG. So if you didn't know, SVG is now part of issue 6 of the specification. It's in actually detailed 732, chapter 732, and you'll see down the bottom it's been added in the S1000D SVG profile. So that's where you'll find the information on it. But just going back to CGM, which really was the original 2D graphics file format, there are 4 versions of CGM. And CGM really was chosen or selected by the spec a long time ago because of its interoperability. So it's an open format, as is SVG. But at the moment, we'd still probably recommend that you create CGMs and use those as your kind of your source file, and then from there save as an SVG, mainly because of interoperability. Because CGM was really more designed as a data exchange format, where SVG was very much designed to display on the web. So how do we put hotspots in? I did actually show you a second ago that you can have metadata within a CGM file, a CGM4 file, where you can have hotspot information. So what you can do then is actually link that metadata to an XML file. We can also create what we call an XML companion file from CGM called an XCF, which gives us the ability to add more information to the illustration. And I'll give you a demonstration that in a bit. On the SVG side, one of the benefits of SVG is it is an XML format, and it's also actually HTML5 native, so you don't really need a plugin to actually display the file. And this was one of the big reasons that a lot of organization and projects went to it, is because there was no plugin required. But CGM now, we can also have no plugin for CGMs as well using our technology VisXview HTML5. So it is possible to use either file format without a plugin now. So the SVG specification is really large. The tiny one was, so there was the full and then tiny. So the actual SVG profile that we developed was basically based on the tiny format, because that's really what you would need to actually display the files. And I think the S1000D profile is the same. So the benefits of SVG is very similar to actually CGM, that it supports metadata, so you can have interactivity like hotspots in there. You can embed raster images, so if you've got legacy data, they could also be displayed. It also has some 2D animation capabilities, and it could also be data driven from a spreadsheet or database. So there's quite a few benefits to using SVG when you're in your publishing of your IETM. So the profile, then we can say hotspot. There's a hotspot definition within the specification now for SVG. So I've just taken an extract out of the spec. As I said, it's in 732, and you can see that it's very, very similar to CGM in the way that it's actually called. So very easy to do the same linking as that you would do in CGM within your ITM. So let's look at interactivity. So in this particular, I'm not going to actually name this chapter, quite a long one, but you can see here the relationship to CGM version 4 and also relationship to SVG 1.1 is the hotspot constructs are within this chapter. So what do we need for a hotspot to work? At the kind of lowest level, you need a data module, and you also need either or an illustration in CGM file format or SVG. Optionally, you can also have with a CGM an XML companion file, which would also give you the ability to have hotspots, but also enter other information. It could be something that you can't put into the CGM. It's just it's not viable because it doesn't support it within the CGM, but you could have it in a companion file. The IMF is fairly new, but that gives you the same capabilities as the XCF file or the XML companion file, but it's more designed to actually manage the file, manage the ICN in a database more tightly. So it gives you more of the abilities that you have within a data module to actually manage the data. So you might want to explore that, but it's optional. It's not mandatory. So basically, what we need is an XML file or data module. We need our CGM or SVG, and then we have that option to either use an XCF or XML, an IMF file to have that interactivity. So you do need to have kind of at least two components to have interactivity within your IATM. So this slide shows the main part of the slide, the XML, shows you the markup within the XML file to actually make this hotspot work. You obviously need the corresponding illustration, but basically the actual linking between the two is done using the application structure. So here we have this hot 001 and then the name. So both these components are within the CGM file, which we enter by creating a hotspot. And the same would be applicable to the SVG as well. In the XCF file or the XML companion file, this is a separate file, but this time the hotspot information is contained within this XML file. So, so it gives you the region of the file, where the hotspot is, and obviously the name of it, and the ID as before. And then the ICN is similar again. So the IMF file is similar again, where it contains information like the hotspot ID, the name, and in this case, it also has a title. It could be a tooltip or something like that. So let's go to the second demo. So how do I add a hotspot to this illustration? So we have a specific tool, a call-out tool, which really would give you the ability to add this really quickly. So we can say the next call-out I enter will be 1, so I can just click, and it will go around. I can annotate this up. At the same time, if you look on the left, what's happening is it's entering, excuse me, hotspot information. So let's just show that. I'll enter another. So it's just added them to the tree view here. And if I show the thing, you can see that these are actually hotspotted. Okay, so that's the very easy way of adding hotspots to this illustration. Well, excuse me. Okay, if I want to create an SVG from this, so this is CGM at the moment, then I just say save as. And there you can see I've got SVG set and it's got the profile for the issue 6. So once you've saved that, we're compliant. And if they were using CGM, again, issue 6, or we can go back to 4.1, 4.0. Okay. I might just go on mute a minute just to get my cough out of the way. Sorry. Sorry about that. Okay, so we also have the ability within here to create that export, that XCF file. So that would create that file automatically for us. Okay, so let's just move on. I'm going to show the viewer at this point. So we've created the hotspots. So how do we view those in our IATM? So this particular one is showing the hotspots, but I'm seeing a tooltip. I don't know if you can see it in Spanish. This is coming from that XCF, that companion file. So if I go to English, go across, and I'm in English. So this is not coming from the hotspot directly within the CGM. It's actually coming from that XML companion file. So that's hopefully a good example of how the companion file could be used because you couldn't contain a translation within the CGM itself. So now I'm going into another viewing environment. Just like to thank Raytheon who given this demo to us of their Eagle Vision, which is their IETM. And I just want to show you the, in this case, the S1000D bike. And if I just go back to visit, said it a minute. So the bike is one of the examples that you get when you download the specification. You can download that. So this has all the hotspots. So I haven't created this. This was created by the S1000D community. And we can see the hotspots on here. So this is the illustration itself. But within here, we have that same example. I'll just try and find, it's actually the illustrated parts data example. If I just move down, I should see it. Just trying to find it. All right. So various things in here which will have graphics, but I'm trying to find the one with the hotspots. Should be here somewhere. Can't see it at the moment. Just bear with me a second. There we go. So here's the bike. They have modified it slightly because what they wanted to show is if I click on a number here, it highlights on the left-hand side on the text and vice versa. I can click on the text itself and it will highlight in this direction as well. So one of the things that's slightly changed is if you noticed on here there's actually 4 number 4s kind of thing. So if you kind of set it up correctly, that you can highlight, if there's multiple parts that are the same, you can highlight them all at the same time by having one link. What Raytheon also have done here is that, say you wanted to order a part, here they've added a shopping basket, so you can quite easily go to the shopping basket here. So that should have added that particular part to your cart. Okay, so this can all obviously all be done because of the interactivity we've got built into, in this case, it's actually an SVG file which was converted from CGM to display it on the screen here. Okay. So now let's go back to the guidelines, but this time 3D. So there is a chapter within the issue 6 of the spec, 3925, that gives you some kind of high-level guidelines for 3D content. It is quite high level though. So if you're going to use 3D, what do you need to do? Well, first you need to gather the engineering data that you need, which will be step one. And obviously that's the reliable information that you can then use to either create your 2D or your 3D illustrations. Step two, if you're creating a 3D scene though, that's there's more guidelines applicable to that within the specification. So how you would create it, what are the guidelines to actually display it on screen? The important thing is that you are actually creating these illustrations from engineering data. In theory, you shouldn't really be creating 3D information outside of that. So certainly with S1000D, the reliable information is from engineering. So S1000D doesn't really, at the moment, recommend a 3D file format for publishing, and that's quite important. That it doesn't this say anything to say you should use this format and this is the format we recommend. It does say though that you should actually in your business rules outline what you're using as your solution for 3D. That does kind of provide like an opening or a loophole if you wanted to use proprietary file formats, which I would not recommend. I would always use open file formats as like CGM, SVG, and so forth for 2D. The kind of risk by not actually defining a format or proposing a format is the fact that people will use different ones. So then IETMs would have to perhaps support different viewers. But our advice is always use an open format. So the first step would be, if you've got 3D, that you might want to go to 2D with it. So it kind of might seem it defeats the object, but if you're still using 2D, then you still want to use source data for 3D to create this new illustration. Now, STEP is the format I mentioned earlier, which is really supported by really every major CAD system. It's an open format. It's actually referenced within the S1000D specification as a recommended file for actually interchange of data. It's interoperable between CAD systems. It's supported by all major CAD systems. It's referenced in the in the S1000D specification. But you've got to consider that it's a large file size, so it's certainly not suitable for publishing within an IETM. Not recommended because the file sizes are extremely large. Plus, it's your engineering data. You don't want that to be going to end users particularly. So I'll do a quick demo of how we get it from 3D to 2D. So this is a VisX Edit 3D, which is obviously our software for handling 3D files. I'm just going to bring in a step file. So usually we'd see .stp, but it signifies step. This is not a large file, so just for expediency, we'll bring this through here. I'm going to do an explosion of this, a quick explosion of this file. Okay, and so I could just begin to pull this apart. I'm not going to do the whole thing. Just grab these bolts. And just pull this one there. Okay, so once I've got the illustration that I'm looking for, I could just save this explosion now. I can go back to it and now say I want to export this as a CGM file or as an SVG file with hidden lines removed. So now I've got an illustration that I can say is should be good because of the fact it's from my engineering data, but also the fact that it's going to be compliant with the specification, and I can add my different kind of annotations, hotspots to it. So this is going to open hopefully within VisX Edit once it's done the hidden line removal. Obviously, that was a very quick file to do, and then you could add in your annotations to this with your hotspots. You can save it as an SVG as well. So once you've got it from your CAD data, you could go to SVG or CGM and use within your IATM. So that's one way we could use the 3D data. Let's just go back to the slides. The other way is actually to retain the 3D and use 3D within our IATM. So going back to that chapter 3925, these are the guidelines again. As I said, they're high level. There's no file formats mentioned. So really, you can't, as long as you document what you're doing, I think in your business rules, then I think you're good. The 3D information, it can be really useful if you're trying to explain something like a complex procedure, perhaps with animation. It could also use as a three-dimensional IPD, illustrated parts catalog. But as I say, any solution you use should be described in your business rules. So some of the guidelines are that text, if you've got text on these 3D illustrations, they should what we call billboard, which means they should always face you as an end user if you're using the IATM. So they shouldn't be moving in 3D space, which is, yeah, that should be kind of fundamental to anything that you do because you need to be able to see it. You should also try to use things that would be in the 2D as well. So like location things and warnings and cautions and so forth should also be done. And everything should be really, if things are moving, they should only move in a way that is possible for the maintainer to do. Color is probably the same guidance as 2D. So like warnings and cautions and so forth. Cautions are red, warnings are amber. So everything if you have to have on the 3D warnings and cautions, they should have the same kind of color that are used within the 2D. And then you can have predefined camera positions. So as I said, this is very high level. It gives you some guidance of what the viewer should be able to do. And certainly from our viewing technology side, we've tried to adhere to these guidelines. But strangely, even though it's 3D, isometric is still like a preferred kind of starting point for the content to view it. So talking about a publishing format, something that you would take from the from the step file and then save into something that's more applicable or usable within the web. Now, we actually selected a format, although we support other ones, but our primary format is GLTF. It's an open format. It's very kind of light, so it could be used really on many devices, in desktops, laptops, even in mobile devices. So it's very efficient. It optimizes the size of the 3D file, and it's also supported by major vendors like Microsoft and Adobe. Also, you can animate parts and sports animation and things like that, and no plugin is required for an IATM. So a bit like SVG. So this is the final demo. I'm going to use VisX Edit 3D again, and I'll show you a quick Eagle Vision from Raytheon again, just to show you an example. So first I'm going to open VisX Edit 3D, which was It is already open. I'm going to close this down. As opposed to explode it, I'm going now just to quickly do a quick animation of this. So if I click new, and this would be step one. So this might, if it's a procedure, this would be step one of my procedure. I can move this part away, as I did before, an explosion, but this time you can see there's a timeline down the bottom here. And I can apply that now. So it's actually created an animation of this, which I can then play back. So this is obviously the authoring environment, but I could also now put that into my viewer. And because this is step one, what we've created within this, which will eventually be a GLTF file or GLB file, is a marker within that file. So then we could trigger that when we go into the item to trigger step one. So next step, step two. So this time I'm just going to select multiple items. And apply that. So now I've had two steps, and then I can keep going and going, adding more steps, and I'll show you in the viewer what that will look like eventually when you've completed it. So once you've finished, I can just say finish this animation. There's step one, step two. I can play those back just as a test. I can also create a reverse of these as well. So if I was now play all, we should see disassemble, and then reassemble. And then I could export this out as this time a GLB file or a GLTF file for my 3D, to include in my 3D IETM. What we also did is we added in a new thing for export video. So if you didn't have a 3D viewer, you could also create a video of this as an MP4 or MP3 file, and then so you could still include it perhaps within the item and just have the animation part. Okay, so let's just go back to Eagle Vision. I'm going to go back to the home button here, and we have a 3D demo here, and hopefully it's this particular part. Yeah. So now we've completed our animated illustration. If I just scroll down, so this is your data model here, but now I have steps. So that step that I put into that GLB file, I can now trigger from here. Step two, I can still resize this. It is three-dimensional, as you can see. Let's just do step three. And then step four should actually change the camera position. So we could also do that within the authoring environment, which is Visx Edit 3D. And then we'll just keep going. And then step eight, actually rotate. So we could, within the authoring environment, we could also rotate parts. We can highlight them. We can flash them. So you've really got a lot of functionality that you can author into these 3D files to make it as usable for the maintainer as possible. So this is kind of a real life example where we've got a 3D viewer, we've got the IETM, and we've got the XML, or rather than me just show it in a normal browser. So it's kind of more real life. Okay, so let's go back to the slides, and that was the last demo, and we now have the last slide, which just in summary, we have a heavy focus at Larsen on S1000D and compliant to those specifications, and we'll continue to do that. We were really focused on SVG, came up with our own SVG profile before the one went into the spec, and we're now compliant with that profile. We're putting a lot of effort into developing the 3D side, with 3D technical illustrations. We're not lost focus on 2D, so we have the HTML5 where you can view CGM graphics without a plugin. We also have an SVG SDK as well, which gives you a head start if you want to implement an SVG viewer in your IATM. So we have an SVG SDK. It's kind of off the shelf, ready to go viewer for SVG. And then we have the VisX View 3D SDK, which you saw that was actually what we've seen within Raytheon's Eagle Vision. They have implemented that SDK within their technology for viewing 3D graphics. As I said, our focus is on S1000D. Among trying to create illustration tools that are kind of applicable across many industries, but we will continue to comply with that specification as we move forward. Okay. So apologize for my voice. It nearly went at one point, as you could tell. So I've got Don on, and Don, if you could rejoin me and perhaps see if we have any questions.
Yes, we do have a question.
Okay.
The question is, has there been any engagement with the regulatory agencies regarding the use of 3D within regulated documents such as overhaul manuals? So I think that's a very good question. Yeah, what do you know about that, Dave? I can.
So I'm thinking of maintenance, repair, overhaul. We haven't had any engagement directly. All I do know is that it really depends if. That's a good question. We certainly haven't anything. S1000D obviously has a connection to commercial aircraft because some of the some aircraft now support S1000D, like the 787 and so forth. If they're using 3D, again, I don't believe there's any kind of regulation documents or any documents that say you have to use a certain 3D file format within there at the moment. So we're quite happy to talk to you about that. But yeah, I don't believe there is anything specifically that says you have to use this file format.
Yeah. Well, I guess S1000D would be the obvious place for it to start. I think there's talk there and discussion about it, but I don't think anything has actually happened within S1000D on that. I know we know the U.S. military is planning to use it, like the U.S. Navy. That will hopefully that'll drive some of it, the need to kind of make the standards bodies get involved.
Yeah, I think the most important thing from our standpoint is that we use the file format that is open, and it doesn't require a plugin. So if you're looking to distribute that information to the end user, to the maintainer, one is they shouldn't be concerned about viewing it. You know, they shouldn't need to download another piece of software to actually view the file. One that it can also be viewed quickly and easily. You know, it's not a very heavy format where they're waiting for it to download or render. So that again, why we use the GLB GLTF format. And it's working. You know, it's actually being used in live projects. So like I say, if you're within the S1000D community, if you document that, then you should have no issues. So the question about our tools, which of your tools require licensing? Pretty much everything we've shown today, VisX Edit 3D. We do have evaluation versions where you can test, but you would need to buy a license to use it eventually. So we can provide pricing. If you want more details on the tools themselves, you can go to cgmlarson.com. I put that in the chat. And there you can visit a website and you can request an evaluation version, or you can email me or Don directly. I'll just put my email in the chat as well. So if you want to evaluate following today's webinar, please just send us an email or go to the website and request one. It might be best just to come to me directly if you're interested in evaluating. I've just put my email in the so
Might be worth noting how it works for the authoring versus the viewing. In other words, the authoring needs a desktop license to author, let's say, CGM or SVG or GLTF,
yeah,
but for a viewer, you need a viewer that's usually part of your, like if you have an S1000D system, you need a viewer that has to be licensed and integrated by the vendor of the system.
yeah. I would say the beauty of CGM though is that really the CGM we create is compliant with S1000D, so it should work with any viewer that is also compliant with the system. 3D's a bit more kind of complicated.
Yeah.
Yeah, so the viewer SDKs do have to be licensed, but it depends. If you're working with a vendor who has already provided you with an IATM, then it's possible they've already done that, implemented it. We do have an evaluation version of the viewer SDKs as well as the kind of off-the-shelf authoring tools like Visx Edit and Visx Edit 3D. So if you want to kind of evaluate any of our SDKs, viewer SDKs, we can provide you links to those as well. Is the exported generated .glb 3D file editable in other multimedia creation tools? Yeah, it should be. Yeah, if the GLB that we create is like the open format, so you should be able to use that in other tools. Yeah.
Yeah. The only thing I'd add there is it differs. There are some limitations if it's animation.
Yeah, possibly. Yeah.
Yeah. Right.
Yeah, because the other thing that GLB and GLTF allow you to do is create extensions, which we've documented. So not it didn't do everything we wanted it to do, with certainly with animation is concerned and annotations. So we did add in some things, but we've documented those publicly. So if you've got your own viewer, then you can easily kind of support those things that we added in. Okay. Yeah. So if the question here is that they've already have their own viewers for their ITM, produce their own ITM. So yeah, if it's if you've got a CGM viewer in there already, then our CGM should work within your viewing environment. If you've got a 3D viewer implemented, then it really depends on what format it supports. We do support other formats other than GLTF and GLB. We support VRML, I think X3D, but we certainly recommend GLTF, GLB. It's probably the most versatile. Okay. Okay. So just yeah, this is more of a statement. So if you want to check what 3D formats you use, then that's fine. You can get back to us. Or as I said, we do have the 3D SDK you can evaluate as well. We can send you a link to do an evaluation of the 3D SDK. Okay, I think that might be it. Great. Yeah. So yeah, thanks everybody. Apologies for my voice. I thought it was going to fail completely on me at one point, but I kind of fought through it. So yeah, we've been also testing out a new platform for webinars today, which is based on Microsoft Teams. Hopefully everything was good for you on your end. If you want to give us any feedback on it, we'll be happy to take that. It might not be the one we use next year, but it seems to have gone well. We have recorded the event, so that should be available to everybody who's attended. I'll make sure it is. As I said, there was a link early on. in the presentation. I'll put that in again if you want to download any of the things we actually showed today, materials. So I'll just put that back into the chat. So you can just click on that link, copy that link, and you can download the materials. It's in a zip file. Yeah. So yeah, thanks for everybody attending. Thanks for the kind words in the chat. And I just, as final, I just wish you happy holidays and a new year. We're obviously back in the new year. I'm not sure when our first webinar will be. Usually would be February. Topic is undecided at the moment. But yeah, we'll hopefully see you again. Thanks for attending today, and hopefully see you again in the new year. Okay, so thanks everybody. I'm going to end the event. Thanks for your attention today.